Hypothesis testing. First, let us define what is a hypothesis. Validating the hypothesis about given data. This means that you are confirming and analyze the given data to validate the hypothesis, whether it is true or false. Expectation. Concerning relationship between variables relationship. It is the expected result, based on the study, between relationship of variables. It states what the researcher thinks the outcome of the study will be. Let us proceed to the types of hypotheses. Firstly, is the null hypothesis, which denotes H sub O. Let us define as a hypothesis statement, with no relationship or differences between variables. Can be a negative or positive form. When you are stated, a null hypothesis in negative form, it contains negative word, like no, not, none, while positive form contains positive word, like same, similar. For example, positive form, H sub O, civil engineering student, and chemical engineering student, have similar, mathematics solving skills. Notice that the positive word is, similar. Another example is for, negative form, H sub O. There are no differences, in civil engineering student, and chemical engineering student, in mathematics solving skills. Notice that the negative word is, no. Let us proceed to the second types of hypothesis, which is alternative hypothesis, which denotes H sub I, which defines as a hypothesis statement, which states with a relationship or differences between variable, can be directional or non-directional. In directional, alternative hypothesis, H sub I defines as a hypothesis with bias in favor in one variable. For example, civil engineering student are good in mathematics solving skills than chemical engineering student. In this example, we notice that the alternative hypothesis are in favor to civil engineering student. Another alternative hypothesis, H sub I, is non-directional, which define as the hypothesis without bias and not favor in any variable. For example, there are differences in civil engineering student and chemical engineering student in mathematics solving skills. In this example, we notice that the word resulting not favor for both variable is the word differences. Let us proceed to the next topic, level of significance. Let us define first a level of significance as the significance level of a test is the maximum value of the probability of rejecting null hypothesis, H sub O. 5% level of significance means that the statistician is 95% confident that decision made is right. However, 1% level of significance means that statistician is 99% confident with the right decision. Let us proceed in the topic, one-tailed test and two-tailed test. For one-tailed test, if the alternative hypothesis, H sub I, when statistician used greater than the normal curve, rejection region are to the right side. Again, one-tailed test, if the alternative hypothesis, H sub I, used less than the normal curve, rejection region are to the left side. If the alternative hypothesis, H sub I, used equals, the rejection region will locate on both sides. Let us proceed to the step-by-step procedure in conducting hypothesis testing. The first and foremost, step 1, construct null hypothesis, H sub O, and alternative hypothesis, H sub I, in words or symbols. Previously, we learned the principles behind constructing the null and alternative hypothesis. Now that we have already established the null and alternative hypothesis, let's proceed to step 2. Set level of significance. Mostly in problem solving, level of significance is given. In other hand, statistician which conduct study are the one to set level of significant. In additional of step 2, determine what types of tailed test. This was based on step 1 you constructed. Now that we already constructed null and alternative hypothesis, then we determine the level of significant to be used, and knowing the types of tailed test. Let us now proceed to step 3, which we use the statistical test. We have two types of test, the z-test and t-test, so how would we know, and when to use the test? The answer was based in sample, which denotes letter n. If the sample, n, is equal or greater than 30, will be used z-test.
Z-test was categorized into two cases, sample mean compared with population mean and comparing two sample means. The formula we used for sample mean compared with population mean is shown, where x is sample mean, me is the population mean, SD is the population standard deviation, and n is the number of item in sample. The formula in comparing two sample means is shown, the x sub 1 is the mean of the first sample, x sub 2 is the mean of the second sample, n sub 1 is the number of items in the first sample, and n sub 2 is the number of items in the second sample. SD sub 1 and SD sub 2 are standard deviation of sample 1 and 2 respectively. If n sample is less than 30, the three cases will occur, such as sample mean compared with the population mean, comparing two sample means, and comparing two sample means with paired observations. Please take note for the formulas as shown. In case letter B, the d sub f was degree of freedom, d sub o is the observed difference. This is 0 if not given. After we already know the z computed or t computed value, let us proceed to the next step. Step 4. Determine the critical value. For z-test, use z-table. For t-test, use t-table. You can also find a complete table of this test in the internet. Now that we already have value of z or t computed from step 3, and z or t table value from step 4, let us proceed to step 5, which is to conclude. We reject null hypothesis denotes as HO, if the computed value lies within rejected region. If your alternative hypothesis use greater than, the rejected region is at right side, and acceptance region at left side, the z or t table value is the critical value. Again we reject null hypothesis HO, if computed z or t value lies rejection region. If alternative hypothesis use less than, the rejected region is at left side, and acceptance region at right side, the z or t table value is the critical value. Again we reject null hypothesis HO, if computed z or t value lies rejection region. If alternative hypothesis use equals, the rejection region is at both sides, and acceptance region at the middle, the z or t table value is the critical value. Again we reject null hypothesis HO, if computed z or t value lies rejection region. In other way around, we accept null hypothesis HO, if the z or t computed lies in acceptance region. In part 2 lets us solve problems. Be sure to like and subscribe for more.